A vintage model traction engine restoration. This is part 16. The last few jobs except for fitting the new steam whistle. This is just about the last episode, apart from the one where I run it on coal and explain how to do it generally. And this episode shows me struggling to fit the dump pin into the ashpan. It's just a bent piece of mild steel and it's subject to a lot of heat and corrosion, so it's very difficult to fit and remove. My solution is this. It's a stainless steel dump pin. I just bent this up from a piece of stainless steel. It fits in the hole perfectly and is very easy to pull in and out. It's never a good idea to use mild steel for a dump pin. It just doesn't work over time. This part of the video should really be called a top tip. I want to clean the inside of the check valve without dropping the entire thing into my acid bath. So I clamped it in the vise very gently and poured a very small amount of acid into the check valve and then heated it up with a blowtorch. The acid that I use is kettle descaler. It's called Kilrock K. I boiled it up in the check valve and then left it there for about 2 hours. So the inside parts are now thoroughly clean without any limescale. While waiting for the acid to do its job, I thought this would be a good thing to do. Clean up the chimney cap. The design of this is quite good. It just lifts off the top of the chimney so you can clean it and then put it back on again. Now it's time to go back to the check valve. I rinsed it off in clean water. Here I've refitted the ball. And now it's time to seat the ball in position. I'm using a piece of brass rod and a heavy hammer. One blow only. Really, you're supposed to change the ball, but I don't have any more balls this size, pardon the expression. This one should be okay. Here I am tightening the top after applying some Loctite 542. I also applied some Loctite 542 to the main thread and screwed it into the side of the boiler. Hopefully when I pressurise the boiler, this shouldn't blow anymore. I was very surprised in the steam test that the injector worked perfectly. The only problem was the check valve was blowing back badly. Hopefully it should be better now. It's time to make some studs to permanently fit the bearing top caps in place. Here I'm removing the cheesehead bolts that I used to temporarily hold the parts in place. Now it's time to make some studs. This is 5/32 of an inch diameter stainless steel. I can't thread this 4BA directly, I have to slightly turn it down. I'm going to make a separate video showing stud manufacture, and that will become part of my Model Engineering for Beginners series. This is just a fast run through the process. Here's the end product, 4 studs that are more or less identical. If you're new to the world of model engineering, I do recommend that you watch my Model Engineering for Beginners series. It's full of essential and useful information. In this clip I'm fitting the studs using the lock nut method. Put a pair of lock nuts on one end of the stud, then securely screw the stud into position in the bearing block. Then you use 2 spanners to unlock the 2 nuts, but retain one of them, although I did remove both of them in order to fit a washer. I would only fit washers in places like this, when the nuts are going to be moved for adjustment at a future time. I rethreaded the bearing block because the threads were in a bit of a state, and thankfully they're okay. I fitted the top cap behind the flywheel in exactly the same way. Time now to pack the stuffing gland for the valve rod. This is more difficult than it seems because it's very small. The piece of graphited yarn that I'm using here is far too thick. It needs to be a good bit thinner than this. When I poked a paper clip into the stuffing gland, I couldn't actually feel any graphited yarn in there. Also in this clip you can see that the nuts don't look too good on the steam chest, but I don't want to do anything about this. I don't want to do anything to draw attention to the fact that the holes are not drilled in the right place. I got rid of the thick piece of graphited yarn and I'm using a much thinner piece now. It is still a very fiddly job, poking it into place using a paper clip. When I was removing the outer part of the gland, the first nut came off okay, the second one brought the shaft with it. This shouldn't be a problem because they'll go back into position in exactly the same way. Now comes the difficult bit. I have to use the outer part of the gland to press the material into position in the inner part of the gland. This is a good way to do it, but you have to be very gentle. I'm using my Barco spanner and then rotating the flywheel very gently. This allows the valve rod to push the spanner up against the outer part of the gland. Once I fitted the gland nuts, and as you can see the gland is much further out than it was, so at least there is some packing in there now and it doesn't appear to be blowing. It's most important never to over-tighten gland nuts, especially when they're this size. A couple of things are likely to happen. One is you will shear off the studs, or the gland material pressing against the valve rod will make it difficult for the valve rod to move in and out, and in extreme cases this could sprain the valve gear. I've been working on miniature steam engines for quite a long time, and I've developed quite a delicate touch that's firm but fits the parts back in place without breaking them. Having a close look at the valve rod, it appears that there aren't any leaks, but I won't really know until I steam it again. Unfortunately, the check valve was still blowing, so here I'm slackening off the union nut on the check valve and on the injector so I can move the pipe out of the way. The check valve is only leaking slightly, and it would probably be okay with more pressure in the boiler, but I want to have a look at it to confirm that it's alright. I can actually feel a very slight pressure when I put my finger over the end of it, but there's no water coming out of it, which is a good sign. When I use my right angle scriber point, you can see a lot of water comes out, but I can still feel some air pressure. I thought I may as well have a go at remachining the face. How did I do that? I put the check valve in my 3-jaw chuck, holding it by the threads quite lightly, and then I used a 1/4 inch diameter end mill in the tailstock chuck, just to reface the inside of the check valve. This usually works. I reseated the ball with the hammer and the piece of brass again, and when I refitted the check valve it wasn't blowing. I noticed that the cap on the injector was blowing a bit, so with the help of a bit of Loctite 542, I'm sealing that. And yes, for all the engineers who watch this and comment, I am aware that I didn't fully tighten the adjustable spanner. This arrived in the post from Jubilee Fittings today. It's a number 8 vertical injector for my large traction engine, and as you can see, it's considerably bigger than the one on this engine. The last part of the job was to fit an O-ring on the cap that goes on the water tank. This should stop some of the water from splashing out of the tank when the water valve is in bypass mode. In this clip, as I'm running the engine, I have the water bypass valve closed. So water is being pumped into the boiler, and this is evident by the level in the water gauge glass. So that's it for this episode, and it's nearly the end of the series. There will be one special episode of me showing how to cold fire a miniature traction engine. Please stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.